Okay, so if they ask you to find an algebraic expression or equation for this table right here, what you might do is to first look and see that our x values are going up by 1, right? It goes from 3 to 4 to 5 to 6 to 7. So they've arranged these x values in ascending order. And the same is true for the y, except I notice they're going up by 2 each time. So what I often like to do first is to extend the table backwards to see what will happen when x is 0. That's usually a very useful step for me. So if I go back to x equals 2, y should equal 2 less than 5, right? Because it's going down by 2 now. And that's 3. If x is 1, y would be 1, right? You see that go down by 1 and go down by 2 here. And then if x is 0, I ran out of room, y would be what? Right up here. X is 0, y goes down by 2, we get negative 1. So that's useful to me because I want something in the form of y equals something times x plus some starting value. And the starting value, this is whenever x is 0. When x is 0. And that, in this case, is negative 1. When x is 0, y is negative 1. So here, b equals negative 1. Right? And I know that my y's are going up twice, right, for every x. So I multiply this by 2x and add those up, and now I have my equation. I would simplify it to y equals 2x minus 1. And if I'm unsure about why this works, I plug in x values. Let's plug in x equals 4. When I do that, I get y equals 2 times 4 minus 1. And that's 8 minus 1, which is 9. Excuse me, 8 minus 1, which is 7, which is exactly what we should get here. Now, if this is not making sense to you, another way to think about it is, okay, well, I noticed that every y is going up by 2. But I noticed that, for example, if I go from x equals 3, I can't just double 3 to get 5. If I double 3, I get 6, which is 1 more than 5. So part of the logic of this equation right here, if you look at it, y is equal to twice whatever x is minus 1. And you can see that anywhere on the table. Like here with 6. If I double 6 to get 12, and then take 1 away, I get 11. So that's part of the logic here in this equation, which is another way of getting at it. I'm just using here a standard slope-intercept form to think about it. All right, thanks.